scientists' terrifying new discovery in Pluto. On the farthest edge of our solar system, bathed in perpetual twilight, drifts a small world cloaked in icy darkness. Pluto, once celebrated as our ninth planet, now reclassified but never forgotten, has remained a mystery, orbiting silently in a realm where sunlight fades into the infinite abyss. When humanity first laid eyes on Pluto in 1930, it sparked our imagination, representing the boundary of our known universe. Yet, in recent years, Pluto has quietly moved from curiosity to enigma. And now, new scientific discoveries have uncovered something deeply unsettling, hidden beneath its frozen exterior. Something that challenges our fundamental understanding of our cosmic backyard. Today, we'll journey beyond familiar skies, exploring revelations from the groundbreaking New Horizons mission and recent startling findings by astronomers worldwide. Together, we'll uncover what scientists are calling a terrifying new anomaly beneath Pluto's ice, a discovery that may forever alter how we see our universe and perhaps even ourselves. Buckle up as we embark on a journey to Pluto, the distant sentinel of secrets, a place where science meets mystery, and what we've discovered might be just the beginning of something much bigger and far more astonishing. Chapter 1. Pluto, the Forgotten World. In the early days of the 20th century, our solar system seemed comfortably familiar. 8 planets circling the Sun, each with its distinct characteristics. But at the edges of our star charts, something didn't quite add up. Tiny disturbances in the orbit of Neptune hinted at something unseen, something hiding in the shadows beyond. It wasn't until February 18th, 1930, on a chilly winter morning in Flagstaff, Arizona, that a young astronomer named Clyde Tombaugh made a discovery that would captivate the world. Working meticulously at Lowell Observatory, Tombaugh sifted tirelessly through images of the night sky, comparing photographic plates night after night. And there, among thousands of stars, he spotted it, a tiny point of light, shifting ever so slightly against the fixed backdrop of distant suns. This faint glimmer wasn't just another star. It was a new world. Pluto had been found. The discovery instantly electrified the public imagination. Pluto, named after the Roman god of the underworld, became the enigmatic ninth planet, situated at the mysterious frontier of our solar system. It was small, distant, and unimaginably cold, but Pluto captured hearts and minds like no other planet before. Newspapers worldwide heralded the discovery, and for decades, generations of children grew up knowing Pluto as one of the 9 planetary wanderers circling our sun. Yet, Pluto was peculiar. It was not only the smallest known planet, but also orbited differently, inclined at an angle, following an elliptical orbit, so stretched that for parts of its 248-year journey around the sun, it wandered closer than Neptune. Scientists puzzled over Pluto's eccentric behavior and distant loneliness. Even as telescopes improved, Pluto stubbornly remained little more than a blurry dot, defying deeper exploration, its secrets safely hidden in the cold and darkness. But as decades passed, Pluto's planetary status came under scrutiny. As our technology improved, astronomers discovered many similar icy worlds beyond Neptune, each orbiting in the distant region known as the Kuiper Belt, a vast, mysterious zone filled with countless icy objects. Suddenly, Pluto wasn't alone anymore. In 2006, Pluto's planetary status became one of the most controversial scientific debates of the century. At an international astronomical conference, after heated debates and passionate arguments, astronomers made a decision that resonated emotionally around the globe. Pluto would no longer be classified as a planet. Instead, it was given a new status, dwarf planet. For many, it felt like an unfair demotion. A beloved planet reduced in status, a victim of scientific rigor. But Pluto, distant and indifferent, continued its quiet, lonely journey, unaware of human classifications and controversies. Yet, what seemed like a setback became a catalyst. Pluto, despite, or perhaps because of, its demotion, was about to receive unprecedented attention, with scientists now more determined than ever to uncover its secrets. What was it about Pluto that so stubbornly captured our imagination? Perhaps it was the mystery, the unknown, the quiet defiance of being a world at the edge of known space. Scientists, driven by an insatiable curiosity, began to prepare an ambitious mission to visit Pluto, to reveal its hidden face, and to finally answer the questions it had guarded for so long. Little did we know, however, that sending a spacecraft to Pluto wouldn't just answer old questions. It would introduce startling new ones. Questions that could reshape our understanding of not only this icy outpost, but perhaps our entire solar system. Chapter 2. Journey to Pluto, the New Horizons mission. The decision to visit Pluto wasn't one taken lightly. It represented humanity's insatiable curiosity and unyielding drive to explore the unknown. For decades, Pluto's enigmatic blur was all we had, teasing astronomers with hints of icy landscapes hidden beneath a distant veil of darkness. But by the late 20th century, dreams of exploration took shape. Pluto, a frontier world situated billions of kilometers away, was finally set to receive its first visitor from Earth. NASA named the mission New Horizons, a fitting title for humanity's unprecedented journey into the cold unknown. Launched on January 19, 2006, from Cape Canaveral, aboard one of the most powerful rockets ever built, New Horizons set out on an odyssey spanning nearly a decade. The spacecraft's target, a faint speck of reflected sunlight, waited quietly at the solar system's distant edge. New Horizons wasn't just any spacecraft. It was the fastest spacecraft humanity had ever built. Traveling at speeds exceeding 58,000 kilometers per hour, it swiftly passed the Moon's orbit in mere hours, a journey that took Apollo astronauts several days. Still, despite this blazing speed, Pluto was astonishingly distant, requiring a voyage of almost 10 years through the cold vacuum of space. Along the way, scientists and engineers held their breath, meticulously tracking and guiding the tiny robotic explorer across an ocean of emptiness. For nearly 10 years, New Horizons raced through silent darkness, occasionally waking from electronic slumber to snap images and collect data from space along the way. It was a test of patience, endurance, and remarkable engineering precision. The tiniest error in navigation could cause New Horizons to miss Pluto entirely, hurtling off forever into cosmic oblivion. Finally, after billions of kilometers and nearly a decade of flight, New Horizons began its approach in the summer of 2015. Scientists and engineers, exhausted yet exhilarated, watched anxiously as images from the spacecraft arrived, starting first as blurry pixels and gradually sharpening into stunning clarity. Pluto, previously seen only as a vague dot, revealed itself to be a world unlike anything we'd imagined. July 14, 2015, became a historic date. New Horizons flew past Pluto, coming as close as about 12,500 kilometers from its icy surface. During the flyby, the spacecraft collected a treasure trove of data, capturing breathtakingly clear images and uncovering shocking new details. The images stunned scientists. Immense glaciers of nitrogen ice, towering ice mountains higher than the Rockies, vast plains covered in smooth frozen fields, and deep, dark canyons. Pluto wasn't just a frozen, lifeless ball. It was surprisingly alive, geologically active, and far more complex than anyone anticipated. One region, named Sputnik Planitia, revealed a heart-shaped glacier stretching over 1,000 kilometers, its surface smoother and younger than expected. Pluto's landscape hinted strongly at active geological processes that required internal heat, possibly even subsurface oceans. But the mysteries didn't end there. Pluto's largest moon, Charon, also proved astonishing. Images captured by New Horizons showed dramatic cliffs, deep valleys, and enormous canyons etched across its surface. Charon wasn't merely Pluto's satellite. It was a complex world in its own right, adding layers to the enigma scientists faced. Yet, amid this triumph of exploration and discovery, New Horizons had captured something else, something profoundly puzzling, something scientists initially struggled to understand. In data transmitted back from the faraway probe, scientists began noticing anomalies, subtle but deeply disturbing signs that Pluto held secrets more bewildering and perhaps even terrifying than anything revealed so far. Heat signatures and gravitational data hinted at strange processes occurring beneath Pluto's frozen crust. Unexplained chemical compositions, subtle gravitational anomalies, and irregular thermal readings indicated something unseen, something scientists had never even considered. Pluto's frozen exterior, long considered inert and lifeless, appeared to conceal something remarkable and alarming beneath its surface. Suddenly, the triumph and joy of discovery were shadowed by unease. What was happening on Pluto? What secrets did this small, distant world hold beneath its icy, quiet surface? And most importantly, were we prepared for the answers awaiting us? As New Horizons sailed onward, venturing deeper into the mysterious Kuiper Belt, scientists on Earth began to analyze the data, becoming increasingly aware that Pluto's most profound revelations were yet to come. A new chapter had begun, not just for Pluto, but for our entire solar system. And as we peered into these mysterious depths, Pluto transformed from distant curiosity to a portal of unsettling discovery, reminding humanity that even now, in our modern age, the universe could still surprise, confound, and perhaps even frighten us in ways we had yet to fully comprehend. The real question lingered. What exactly was lurking beneath Pluto's frozen crust? And how might it redefine everything we thought we knew? Chapter 3. The Dark Anomaly. As scientists sifted meticulously through the wealth of data returned by New Horizons, something strange began to emerge. While the surface images captured humanity's imagination and filled scientists with excitement, another subtler mystery quietly took hold. An anomaly buried within Pluto's icy shell. At first, the anomaly appeared as nothing more than curious readings, small irregularities easily overlooked amid the flood of astonishing surface images. But as data poured in, a pattern emerged, and scientists soon realized that something deeply unsettling was hidden beneath Pluto's frozen crust. The discovery started subtly, with unexpected heat signatures detected beneath certain regions, notably beneath Pluto's vast nitrogen glacier, Sputnik Planitia. Given Pluto's distance from the Sun, any noticeable heat was startlingly unexpected. It simply shouldn't exist, not on a world considered frozen solid, cold enough to turn nitrogen itself into ice. Teams of astronomers, geologists, and planetary scientists worldwide quickly mobilized, poring over the thermal maps again and again. Each analysis intensified the puzzle rather than solving it. The anomalous heat signatures weren't random. They seemed deliberate, localized, and structured, almost hinting at geological activity previously believed impossible on such a distant and tiny world. Scientists immediately began theorizing. Could Pluto have an internal heat source, powerful enough to sustain geological activity? Perhaps radioactive decay, deep beneath its icy mantle, was causing pockets of warmth. But simulations and calculations quickly dismissed this possibility. Pluto was simply too small and too ancient for this explanation to hold true. Then came another startling piece of the puzzle: gravitational anomalies. Detailed gravitational mapping from the New Horizons spacecraft revealed irregularities, suggesting Pluto's internal structure wasn't as simple as previously thought. Large mass concentrations, hidden beneath vast plains and towering ice mountains, indicated something dense, something unusual, hidden far below Pluto's icy exterior. Whatever it was, it distorted Pluto's gravitational field in a way that confounded planetary scientists. This revelation drew immediate comparisons to anomalies found beneath Earth's moon, regions known as mascons, which are dense concentrations of mass beneath the lunar surface, typically remnants from ancient asteroid impacts. Could Pluto's anomaly share a similar origin, perhaps resulting from a massive collision billions of years ago? Initially, this theory held promise, but upon closer inspection, inconsistencies appeared. The anomaly on Pluto was deeper, more extensive, and inexplicably linked to the unexpected heat signatures. Then, chemical analysis added another layer of mystery. Spectroscopic data from orbiting instruments revealed bizarre chemical compounds appearing near areas of these gravitational disturbances. Compounds scientists had rarely encountered naturally in the solar system, and certainly not expected on Pluto, such as complex hydrocarbons, organic molecules, and strange isotopes were suddenly detected. The findings set off a frenzy of debate in the scientific community, as researchers struggled to understand how such chemicals could exist in abundance beneath Pluto's frozen wasteland. Some scientists suggested the presence of a subsurface ocean, liquid water existing beneath Pluto's icy shell, warmed by internal processes. Yet this only deepened the mystery. If such an ocean existed, how had it stayed liquid for billions of years? Even more intriguingly, could such environments potentially harbor life, microbial ecosystems thriving quietly beneath Pluto's frozen veneer? As astronomers around the world debated, the mystery grew deeper and, frankly, stranger. Certain scientific circles proposed more speculative hypotheses, from exotic geological processes to unknown cosmic phenomena, suggestions cautiously entertained due to the sheer lack of satisfying conventional explanations. Each theory, rather than solving the puzzle, seemed to add complexity, pushing Pluto further into the realm of cosmic mystery. Public interest soared as headlines worldwide began hinting at discoveries potentially upending our understanding of planetary science. News reports varied wildly, from sober scientific analyses to sensational speculations. Despite attempts to calm public imagination, Pluto had undeniably become a source of both fascination and unease, as people worldwide grappled with the idea that a seemingly simple icy world might be hiding profound, even unsettling secrets. Yet, despite extensive data and countless analyses, Pluto remained stubbornly silent, its anomaly defying easy explanation. Scientists faced a stark choice: accept that Pluto might harbor phenomena previously unknown, or concede that our fundamental understanding of planetary geology, chemistry, and even potential astrobiology might be incomplete. And as Pluto continued its lonely orbit around our Sun, astronomers remained haunted by a nagging sense of uncertainty. Was this anomaly merely a fascinating scientific curiosity, or was Pluto quietly signaling a deeper truth about the universe, something humanity had yet to comprehend? The questions now faced weren't merely about Pluto. They extended outward, implicating the entire solar system, and perhaps our fundamental grasp of the cosmos itself. As scientists prepared to investigate further, one question lingered most persistently. If Pluto, small, cold, and distant, could hide such baffling secrets? What else might the dark corners of our universe be concealing? And what terrifying new reality might we uncover next? Chapter 4. What lurks beneath Pluto's surface? As astronomers wrestled with Pluto's puzzling anomaly, the question shifted from whether something unusual lurked beneath its surface to exactly what that something might be. Each revelation seemed to pull Pluto further from the quiet, lifeless world we'd expected, transforming it instead into an intriguing enigma at the edge of our solar system. The question was now clear. What exactly was hiding beneath Pluto's icy crust? One leading theory quickly emerged. Beneath its thick ice shell, Pluto could harbor an extensive ocean of liquid water. But how could water remain liquid so far from the sun's warmth, billions of kilometers from Earth, in temperatures plunging below -230 degrees Celsius? The answer, scientists theorized, lay in the mysterious heat signatures discovered by New Horizons. Perhaps beneath the endless frozen plains of Sputnik Planitia, tidal forces or radioactive elements generated just enough heat to melt ice, creating a vast subsurface ocean. This explanation, while astonishing, wasn't unprecedented. Similar subsurface oceans have been proposed or even confirmed on other icy worlds, such as Jupiter's moon Europa and Saturn's Enceladus. However, what made Pluto's potential ocean uniquely disturbing was the bizarre chemical cocktail observed nearby. Spectroscopic analysis indicated that the subsurface region contained strange organic molecules and complex hydrocarbons, chemicals often linked to biological processes or, at the very least, advanced prebiotic chemistry. Could Pluto's ocean be fostering the conditions necessary for life, however alien or primitive? This idea sent shockwaves through the scientific community. Suddenly, Pluto wasn't merely an icy rock orbiting at the edge of oblivion. It was potentially a haven for life, or at least an environment in which organic chemistry flourished in isolation, far from human observation. But not everyone agreed with this explanation. Another prominent hypothesis suggested an even stranger geological phenomenon. Perhaps Pluto's anomaly was caused by previously unknown forms of exotic ice. In the extreme conditions of Pluto's interior, ice doesn't behave as we expect it to on Earth. Under immense pressure and unique chemical conditions, ice could form unusual structures and phases, becoming dense, chemically reactive, or even radioactive, creating strange gravitational anomalies detected by New Horizons. Geologists began speculating openly about these exotic ices. Could Pluto be home to massive structures composed of exotic water ice, mixed with ammonia or methane, forming underground ice volcanoes known as cryovolcanoes? Could these cryovolcanoes be active today, slowly reshaping Pluto's interior, quietly erupting beneath the surface, unseen but deeply affecting the planet's gravitational field? Supporting this cryovolcanic theory, New Horizons images indeed revealed features resembling dormant volcanic cones near the anomaly zones. These enormous cryovolcanoes, unlike anything observed before, could theoretically eject vast amounts of exotic compounds, resurfacing Pluto's terrain and explaining some chemical anomalies. But questions remained. Could such activity explain the persistent heat signatures, or was something else entirely responsible? An even more unsettling hypothesis began circulating quietly among researchers, a scenario rarely considered seriously, but impossible to dismiss outright. What if Pluto's anomaly indicated not natural geological processes, but the aftermath of an ancient, catastrophic event? Perhaps an immense collision billions of years ago with another celestial body. Such collisions were common in the early solar system, shaping planets and moons alike. If such an impact occurred, Pluto might still bear hidden scars. Deep beneath the surface, a dense fragment, perhaps a metallic core, or even exotic materials unknown to modern science, could still linger, generating strange gravitational distortions and chemical reactions. Could Pluto conceal remnants from an ancient cosmic collision, possibly including dense metallic fragments or rare radioactive isotopes buried beneath ice and rock? Each scenario carried profound implications. If Pluto's anomaly indeed resulted from a cataclysmic collision, its interior might house materials unlike anything we've encountered before, pushing the boundaries of planetary science and forcing us to reconsider the history of the solar system itself. Yet, despite extensive debate, none of these explanations fully resolved the mystery. Pluto remained stubbornly enigmatic. Every answer seemed to multiply questions, each scenario expanding the possibilities into realms that both intrigued and troubled scientists. It was becoming increasingly clear that Pluto's secrets might be more profound and potentially more alarming than humanity was prepared to accept. Pluto, a tiny world once dismissed as insignificant, now loomed large in our collective imagination, its mystery quietly rewriting the narrative of our cosmic neighborhood. As the scientific community braced itself for the next wave of exploration and research, Pluto had undeniably changed from a distant curiosity to a focal point of scientific fascination, and perhaps even dread. And as researchers prepared new missions, telescopes, and probes to further unravel Pluto's unsettling secret, a new, equally compelling question emerged. Was Pluto merely an isolated mystery? Or was it a harbinger of deeper cosmic phenomena, lurking within the distant darkness of the Kuiper Belt? Perhaps Pluto wasn't the anomaly itself, but merely the first hint of something vastly stranger, waiting silently in the darkness beyond Neptune's orbit. Chapter 5. Pluto's Connection to the Kuiper Belt Mystery. As scientists continued grappling with the troubling mystery beneath Pluto's icy shell, attention slowly shifted to the broader context surrounding the dwarf planet. The enigmatic Kuiper Belt, stretching far beyond Neptune's orbit. The Kuiper Belt is a vast, dimly lit region filled with icy debris, dwarf planets, and countless frozen remnants from our solar system's early days. Pluto was no longer just a solitary anomaly. It was now considered a gateway to understanding this entire mysterious realm. The Kuiper Belt was only discovered in the early 1990s, changing forever how scientists understood the architecture of our solar system. Pluto, we realized, wasn't alone. It was merely one of potentially thousands of icy worlds, drifting silently through this distant frontier. This revelation reshaped our view of Pluto, but also introduced a chilling possibility. If Pluto concealed something startling beneath its surface, could similar anomalies exist on other Kuiper Belt objects? Astronomers quickly intensified their studies, observing other Kuiper Belt objects, commonly known as KBOs. With increasingly powerful telescopes, the findings soon startled even seasoned astronomers. Several large KBOs, including Eris, Haumea, Makemake, and numerous smaller bodies, revealed peculiar characteristics reminiscent of Pluto. Subtle thermal anomalies, strange orbital irregularities, and bizarre chemical signatures began emerging from these remote worlds. These discoveries forced scientists to confront an unsettling possibility. Pluto might represent only the tip of a cosmic iceberg. The disturbing anomaly detected on Pluto, rather than an isolated oddity, could indicate a widespread phenomenon occurring throughout the Kuiper Belt. One significant discovery involved Haumea, an oddly shaped dwarf planet known for its rapid rotation. Recent observations hinted at faint heat emissions and complex geological structures similar to Pluto's mysterious regions. Though weaker and less detailed, these signatures echoed Pluto's anomalies, prompting speculation of subsurface geological processes or even hidden oceans beneath Haumea's icy exterior. Even distant Eris, the dwarf planet, whose discovery led to Pluto's demotion, wasn't immune to mystery. Advanced spectral analyses revealed chemical anomalies resembling those detected beneath Pluto's surface, further fueling scientific curiosity and concern. Could Eris also be concealing geological secrets or exotic materials beneath its icy veneer? The possibility that multiple worlds scattered across the Kuiper Belt might share hidden anomalies introduced a thrilling yet troubling new perspective. Could the entire region harbor exotic phenomena, geological activity, or chemical compositions never before considered possible in such distant reaches of space? Some scientists suggested that the Kuiper Belt might be experiencing a form of geological awakening, driven by processes yet unknown. Perhaps gravitational interactions with unseen massive bodies, or even an elusive hypothetical ninth planet far beyond Pluto, were quietly disturbing these icy worlds, generating internal friction, heat, and potentially radical chemical reactions beneath their surfaces. Theories about the so-called Planet 9, a hypothetical giant planet orbiting far beyond Pluto, became increasingly relevant. Planet 9's gravitational tug could explain unusual orbital alignments among distant KBOs, subtly influencing Pluto and other dwarf planets. Could this mysterious planet's gravitational influence be the key to understanding Pluto's anomaly and those of other Kuiper Belt objects? Scientists also entertained more speculative, even troubling hypotheses. Perhaps ancient collisions, remnants of cosmic catastrophes, billions of years old, lingered across the Kuiper Belt, embedding dense fragments of radioactive material into these icy bodies. Such cataclysmic events might have seeded countless KBOs, including Pluto, with anomalous compositions and internal structures capable of generating unexpected geological activity today. Each new discovery intensified both excitement and unease. If the Kuiper Belt harbored widespread anomalies, humanity's understanding of our solar system might be fundamentally incomplete. No longer were these icy objects mere inert relics. They were dynamic worlds, concealing active processes, strange chemistry, and perhaps even environments suitable for exotic forms of microbial life. Yet, amid this excitement, an uncomfortable question lingered. If so many distant worlds displayed unsettling anomalies, what did that imply about our broader understanding of planetary science? Could fundamental assumptions about planetary evolution, geology, or astrobiology be wrong, or at least incomplete? Scientists began advocating vigorously for new missions to the Kuiper Belt. Plans emerged to launch specialized telescopes and probes dedicated solely to exploring these distant, icy bodies. Pluto had opened Pandora's box, and the only way forward was deeper exploration, driven by urgency and fascination, to confront whatever cosmic truths lay hidden among these mysterious, distant worlds. As humanity stood on the threshold of an entirely new frontier, the Kuiper Belt ceased to be merely an obscure region on the edge of our solar system. Instead, it had become a cosmic mystery zone, a place filled with unanswered questions, compelling hints of unknown phenomena, and potentially unsettling discoveries waiting quietly in the dark. Pluto had shown us that the edge of our solar system wasn't lifeless or silent. Rather, it brimmed with activity, secrets, and perhaps even threats we were only beginning to comprehend. The Kuiper Belt was no longer a forgotten corner. It had become an urgent mystery, one that humanity was just starting to unravel. But as astronomers prepared new explorations, a question quietly haunted their minds. Could Pluto and its strange anomalies be only the beginning? And if so, what other unsettling truths might humanity uncover in this dark frontier beyond Neptune? Chapter 6. Wider Implications. How Pluto Challenges Our Understanding of the Universe. Pluto's surprising anomaly and its connection to the mysterious Kuiper Belt wasn't merely a scientific curiosity. It had profound implications for humanity's broader understanding of the universe. Until recently, our solar system seemed comfortably predictable. Familiar planets circling a stable star, each world mapped, categorized, and understood. But Pluto's startling revelations upended all this, challenging scientists to confront the reality that we might know far less than we imagined about the universe around us. The first profound implication centered around planetary science itself. Pluto had been widely believed to be a geologically inactive world, frozen and static, simply orbiting in lonely silence. But New Horizons proved otherwise. Not only was Pluto geologically active, but it appeared dynamic, complex, and intriguingly unpredictable. These findings forced scientists to reconsider their fundamental assumptions about small, distant worlds, specifically how geological processes might function so far from the sun's warmth. Previously, scientists had assumed geological activity required large planetary bodies like Earth or Mars, or at least gravitational interaction from giant planets like Jupiter and Saturn's moons. Pluto's anomaly shattered that assumption. Here was a tiny dwarf planet, isolated at the solar system's outer fringe, showing complex geology and possibly even subterranean oceans. This revelation suggested geological activity could be far more widespread and varied throughout the universe than previously imagined, occurring even on tiny, distant worlds, orbiting faint stars, or drifting in interstellar darkness. Secondly, the organic chemistry detected beneath Pluto's icy crust raised astonishing astrobiological possibilities. Pluto, orbiting in perpetual cold darkness, might harbor liquid water and organic molecules, key ingredients for life as we understand it. This challenged long-held beliefs about the limitations of habitable zones and forced astrobiologists to reconsider the criteria for potential life-supporting worlds. Could similar conditions occur elsewhere, even far from conventional habitable zones, dramatically increasing the number of worlds potentially capable of supporting life? Pluto's revelations hinted that life, if it existed elsewhere, might thrive under extreme conditions we once thought impossible. On moons orbiting gas giants, dwarf planets in distant orbits, or even rogue planets drifting freely through interstellar space. The implications were breathtaking. Humanity's quest for extraterrestrial life had suddenly expanded into realms previously thought barren, dramatically increasing the potential abundance of life in our galaxy and beyond. But perhaps even more profoundly, Pluto's anomaly challenged our cosmological understanding. The Kuiper Belt, it appeared, was not just an icy debris field left over from planetary formation. It was potentially filled with worlds harboring complex geology and chemistry, possibly shaped by unseen forces or catastrophic ancient events. Such discoveries suggested our solar system might be far less stable and more dynamic than previously imagined, shaped by violent cosmic collisions, hidden gravitational influences, or even unknown processes occurring quietly over billions of years. The presence of gravitational anomalies beneath Pluto's surface raised another profound possibility. The solar system could contain hidden planetary bodies, dwarf planets, or even more massive worlds orbiting silently in distant darkness, exerting subtle gravitational influences. The controversial concept of a ninth major planet, known popularly as Planet 9, gained new traction, supported indirectly by Pluto's unexplained disturbances. If such a planet existed, lurking far beyond Pluto, it could reshape everything we thought we knew about our solar system's structure and evolution. Moreover, Pluto's anomaly challenged humanity's philosophical understanding of our place in the cosmos. Historically, humans have repeatedly discovered how much smaller and less significant Earth is compared to the vastness of the universe. Pluto's unexpected revelations reinforced this humility. If we knew so little about a small, distant world in our solar system, how much more remained undiscovered throughout the billions of galaxies in the universe? Scientists began to openly discuss how Pluto forced a reevaluation of what we truly know about cosmic reality. We had underestimated Pluto profoundly, dismissing it as small and simple. Yet beneath that icy shell lay complexities that baffled even the most experienced planetary scientists. What other assumptions, scientists wondered, might similarly limit our understanding of other celestial phenomena? Black holes, neutron stars, exoplanets, or even fundamental physics itself. This sobering realization encouraged astronomers worldwide to push harder, observe deeper, and rethink basic assumptions about cosmic exploration. Pluto, once a dismissed world, had become a symbol of scientific humility and curiosity, reminding humanity that vast unknowns still awaited discovery. As the implications of Pluto's anomaly continued rippling through the scientific community, one certainty became clear. Humanity's journey into understanding the cosmos had only just begun. Pluto wasn't merely a dwarf planet, orbiting quietly in darkness. It had become an emblematic messenger, signaling profound truths yet undiscovered about the universe, challenging humanity to explore deeper, question more boldly, and embrace humility in our quest to understand the cosmos. And as scientists prepared ambitious new missions, inspired by Pluto's shocking revelations, a new thrilling question took center stage. What other mysteries, equally astonishing, might the universe quietly conceal? Chapter 7. What's next? Future missions and explorations. With Pluto's mysteries capturing global imagination and challenging long-held scientific assumptions, the demand for deeper exploration surged dramatically. Scientists recognized that Pluto's revelations were not merely fascinating. They represented a fundamental shift, redefining humanity's understanding of our solar system and its hidden depths. Yet, as profound as Pluto's anomaly was, it was clear we had barely scratched the surface of this strange new frontier. The pressing question became, how do we return to Pluto? And what new missions might finally unlock its secrets? Plans quickly emerged to follow up the incredible achievements of the New Horizons mission. NASA, along with other international space agencies, proposed ambitious new probes specifically designed to investigate Pluto and other Kuiper Belt objects. Unlike New Horizons, a fast flyby probe, future missions would include orbiters or even landers capable of sustained exploration. The most ambitious proposals called for Pluto orbiters, spacecraft that could remain in orbit around Pluto for years, mapping its surface in unprecedented detail, measuring its gravitational field precisely, and gathering sustained geological, chemical, and atmospheric data. Orbiters would reveal detailed information about Pluto's internal structure, pinpointing exactly where the gravitational and thermal anomalies originate. With such orbiters, scientists could directly observe seasonal changes on Pluto's surface, study its atmosphere and climate in detail, and search for further clues about the possible subsurface ocean. But scientists quickly realized that to truly solve Pluto's greatest mysteries, direct exploration of its surface was necessary. A lander mission, an astonishingly ambitious goal, was proposed, aiming to deliver robotic explorers onto Pluto's icy terrain. Such landers would be equipped with drills, instruments, and laboratories capable of directly sampling and analyzing Pluto's surface ice, chemicals, and geology. Most intriguingly, landers could carry instruments designed specifically to detect signs of subsurface oceans, exotic chemicals, or even life forms or prebiotic compounds hidden deep beneath the ice. The complexity of such missions, however, was immense. Pluto's distance from Earth posed unique challenges. Radio signals traveling at the speed of light take hours to travel between Earth and Pluto, meaning robotic explorers would need advanced autonomous navigation, decision-making, and troubleshooting capabilities. Scientists and engineers immediately began designing highly intelligent probes capable of independent exploration, adapting dynamically to Pluto's harsh and unpredictable environment. At the same time, astronomers pushed for expanded telescope-based observations. New generations of powerful telescopes, such as NASA's James Webb Space Telescope and future ground-based observatories, would dramatically enhance humanity's ability to observe distant Kuiper Belt worlds. Enhanced telescopic observations would allow astronomers to identify other Pluto-like anomalies across the Kuiper Belt, mapping their distribution, understanding their origins, and potentially identifying targets for future missions. Moreover, inspired by Pluto's discoveries, space agencies began exploring concepts for broader Kuiper Belt missions. Plans emerged for spacecraft that could traverse the Kuiper Belt systematically, visiting multiple dwarf planets and icy bodies. By studying multiple worlds in detail, scientists hope to uncover patterns, correlations, and perhaps universal explanations for Pluto's anomaly, transforming Pluto's mystery from an isolated puzzle into part of a broader scientific understanding of planetary formation, geological processes, and cosmic chemistry. However, the boldest proposals looked even further into the future, envisioning missions capable of drilling deeply through Pluto's thick ice shell. Such ambitious probes could penetrate kilometers of ice, directly exploring the hypothesized subsurface ocean and conducting groundbreaking studies of Pluto's internal environment. Though these missions seemed futuristic, their promise captivated the imagination of scientists and the public alike, fueling dreams of direct exploration and potentially transformative discoveries. Public enthusiasm grew as well, sparking debates, support, and pressure on space agencies worldwide to prioritize Pluto and the Kuiper Belt. Pluto's anomaly, it seemed, wasn't merely a scientific issue. It had become a global phenomenon, inspiring a new generation of scientists, engineers, and dreamers. Pluto had transformed from a distant, forgotten world into a cultural icon, symbolizing exploration, discovery, and the eternal human curiosity to understand the unknown. As plans for future missions accelerated, scientists acknowledged a deeper truth. Pluto had not only reshaped scientific priorities, it had also permanently altered humanity's relationship with space exploration itself. The distant dwarf planet had reignited our sense of cosmic adventure, reminding us that even familiar corners of our own solar system still held astonishing mysteries. Thus, humanity stood at the dawn of a new era, driven by Pluto's mysterious anomaly and the tantalizing questions it raised. Future missions, telescopes, orbiters, and landers were already being designed, promising discoveries more profound and perhaps more unsettling than anything we'd imagined so far. The stage was now set to go for humanity's next giant leap, a leap inspired by the tiny, distant world of Pluto, a silent messenger from the edge of the unknown, whispering truths that would forever reshape how we see our universe and our place within it. As we prepared to return to Pluto, scientists and dreamers alike wondered quietly, what astonishing, perhaps terrifying truths awaited us beneath that icy shell? And were we truly prepared for what we might discover? Pluto, the gateway to the unknown. Pluto, a distant, tiny world, drifting silently in the icy darkness at the edge of our solar system, has transformed from a forgotten dwarf planet into a profound symbol of humanity's unending curiosity. It has taught us humility, challenged our deepest assumptions, and forced us to rethink what we thought we knew. about our cosmic home. When Clyde Tombaugh first spotted Pluto in 1930, nobody could have imagined that this small, faint speck of light would someday reveal secrets profound enough to alter humanity's understanding of the universe itself. For decades, Pluto quietly orbited in darkness, intriguing astronomers but never fully revealing its hidden face. Then, the historic New Horizons mission arrived, illuminating Pluto's icy landscapes and unveiling unsettling mysteries beneath its frozen crust, mysteries that hinted at geological activity, subsurface oceans, exotic chemistry, and perhaps even conditions suitable for life. Today, Pluto stands as a stark reminder that our solar system, and indeed the universe, is far more mysterious and dynamic than we ever dreamed possible. Its strange gravitational anomalies, unexpected heat signatures, and bizarre chemical discoveries have revealed that even distant, seemingly simple worlds may harbor profound, perhaps unsettling secrets. The implications of these discoveries are far-reaching. They force us to rethink where life might exist, how planets evolve, and the possibility that the universe holds countless hidden worlds brimming with unknown phenomena. Pluto has reminded us that scientific exploration is never truly finished, that every answered question raises new, deeper mysteries. As we prepare new missions, telescopes, orbiters, and landers to further unravel Pluto's secrets and explore the Kuiper Belt, humanity finds itself standing on the threshold of a thrilling new chapter of cosmic discovery. Pluto, once merely the cold, distant dwarf planet, now represents the vast unknown, waiting at the edges of our understanding, quietly urging us forward into deeper space, deeper mysteries, and deeper truths about the universe and ourselves. Pluto is no longer just a planet. It has become humanity's cosmic muse, inspiring new generations to explore further, dream bigger, and boldly question everything we think we know. Because if Pluto, so small and distant, can harbor such startling secrets, what other incredible discoveries still lie hidden in the endless darkness beyond? As we look again to the night sky, one thing is clear: our journey of cosmic exploration has only just begun.